Alright, so it's been a while since I looked at this, and I've forgotten most of where I got to. I just remember that the wiring was all up the wop and we had a tone control on the grid of the output bottle and some weirdness going on. It's been sitting on my bench ever since. It's in the way of some other jobs I really need to get on with, including the Pacific set, which, yes, is still sitting in the background, and I really need to get onto that because it's the one big restoration that I'd like to actually finish. This, because I've opened it and I've started to play with it, I just want to finish it. We had a couple of schematics for this set. This is a Courtenay 5C. This is the documentation for a Courtenay 5C, I believe. We have the 5B schematic, which is similar and covered in bugs because it's all been sitting out here for so long. The 5C, there's a couple of different versions. There's drawing 110 and drawing 128, and as far as I can tell, the differences are these are 25k and they're 50k on the other one. This line I think is just simply missing. So we've got our aerial input which goes through this 10k pot here, which is the volume control. So on these older sets the output bottle's driven full hard and it is simply the signal that is dumped to ground progressively through that volume control, which gives you your volume level. So we've got a little bit extra circuitry here. If we take a look at the other circuit, then we have the input to there, which is basically through a 25k resistor split off to ground via a 0.2 and then a 100k resistor onto the main HT line. On the previous circuit that's just a 50k, actually a 500k, sorry, straight from HT. So filtering, perhaps noise filtering, not really sure, but that's on the later circuit. It will have been added for something. They won't have just put it in there for no reason. My guess is that it was filtering of some kind of noise. So we have this 2 meg resistor between the screen grids of the 257s and a 0.1, actually is that a 1 1.1 microfarad to ground? That's odd. We'll investigate further. We've got this 25k screen feeder resistor here, which is feeding that screen, it is feeding that screen, and then a 2 meg resistor feeding that screen. So on the early one it's a 50k screen feeder feeding basically all three screens. Take that how you will. This is a later circuit. Neither one says what they are. They were both drawn by the same person, and the dates are a little bit difficult to distinguish, but it looks like probably only 6 months apart. So not many changes that I've noted, but what are my intentions? I'm not going to rebuild it from scratch. I want to get it working and then get it off my bench. 0.635 meg. In other words, that is way too high for a tone control in this particular circuit. Alright, let's work out what we were doing from here. So what we've got from here is a wire coming back from this pin here. We've got that one there. We need to get 250k to a junction of R1 and 250k, and that R1 is going to depend on our speaker field. So it looks like it's going to be a 2.5k. Yeah. So we've got a 2.5k field coil in this speaker, and chances are that's the speaker that's going to stay in it for the meantime. So 2.5k field coil, 50k. So 250k and 50k to ground. Hi Bud! Bud is in the bedroom, which is just next to the garage. He sits in the bedroom, looks out the window and sees rabbits and barks at them. And his bark is so loud you can hear it through a couple of walls right through into the garage. So 250k, 270 is the nearest we'll get. And what do we say? 50k, so that'll be 47. Now actually, because that one's a bit higher, we'll use a 56, because the ratio is probably not going to be too far off. It'll be near enough for the purpose of this exercise. So we need to go from here, maybe we'll just go to this next tag here, and then from there I can jump her across to this tag and then earth it, because that is actually a screwed on earth terminal anyway. Work out what we've done here. So I've done that, done that, done that, done that, I've done that. Pin 4 is connected to HT. So we've done that. We've done that, and that, and that, and that. So I need to do pin 2, which means we're doing the we need 0.05 and a 20 or 25k pot. This might be a 50. It might be alright. Okay, that'll do. That'll do. So comes with period correct wire, that's handy, although it's probably a bit mangled in there. Wiper goes to ground. So on the inside of here, you can see it or not, there's an earth tab, and that earth tab would have been designed to solder straight onto that tag and save a wire and give a good earth. So that's what we'll do there. That's one wire we don't have to worry about. Not sure whether that's been painted. We'll see how it goes. Alright, so this other one needs to go via a 0.05 to pin 2, the plate. Should you let components hold themselves up? Yeah. In old circuits, or in old components, it's generally pretty fine because the legs are fairly thick. Modern components, leads generally not so thick. So yeah, no, it shouldn't do this, but I'm going to do it. Look away now. It's a temporary repair, and when I say temporary repair, what I mean is it's on my bench and it's in my way and I want to work on something else, so I need it out of the way, but I need it out of the way in a state that is somewhat known. Look at me J-hooking the snot out of this. I thought using components to hold itself in the air was bad. Oh, I can see the steam flowing out of people's ears. Did tell you to look away. So, pin 2 does a couple of things. It goes via a 0.05 to a 25k for a tone control. Which is correct, and it also goes to the other side of the speaker output, which is correct. Pin 2 definitely goes to there, which is fine. This is the other side of there, which should go to pin 4. 1, 2, 3, 4, which it does, and HT, which it does. And it also goes off to here, which it does. So that wire is now traced. Good. That's done. I've wired that. Alright. That, I think, is all of the power supply done. Those two caps I did last time, so they both go to HT. This one goes to ground, which it does. So that, and all of that's done, that's done, that's done. So we're now working from here back. Alright, we need a 0.01, the audio coupling cap. So there's our audio coupling cap. It's going to go to a 250k, which that looks like a 20k, but a big one, so that might actually be that one there. This screen feeder is normally... Alright, this is very frustrating, my camera keeps turning off. Man down. Again, I don't know how much I've missed. I don't know how much you've missed. It's probably just waffle anyway. At the moment, what we're doing is trying to get this wired in. We've got everything in the audio section done. So at this point, I've put the coupling cap, the audio coupling cap here, because that's where it was. But I've just actually realized that to get to the filter, which is here, I'm going to have to wire across to there for no good reason, because I'm wiring basically to here through that cap and then back again. So I'm going to take that back out because there's no point having it there. This coupling cap can come straight from pin 3 straight up to here. So it's going to go from pin 3 up to this 10k resistor, which is actually a 25. And we should measure that. These resistors are pretty reliable. 30k. So it's 6k over, which is what, just over 20% or something. The modern filters use 100 pit caps, but they use a 47k or 50k resistor in here, so the fact that that's a little bit high is not going to cause any grief at all. Alright, audio filter onto there. So this 100k will go between HT and 250k. The 250k will then go to here. So 100k, 250k, and then a 0.2 to ground. That, my friends, is a thing of beauty and a joy to behold. They all seem to have this style of variable resistor in them. This one is obviously dead, and I don't really want to get sidetracked, so I'm going to put that aside for now. We've got something that will do the job, and we can recycle that. Okay, it's not the prettiest thing in the world, but yeah, I just want to watch this tab because it's not too far from here, and I can't remember if it's this one or the 106, but a lot of these models had a metal shield on the bottom, so there was a plate basically earthed that runs right across the bottom, and with that being so close I don't really want to accidentally, although I can probably just bend it. I think that'll be okay. So that's our aerial coming in. Aerial comes in, goes into the coil and also to one end of the pot. The wiper needs to be grounded, so we need an earth wire. Alright, that's earthed. Good solid earth, run along the chassis there. Aerial's into there. Other side of the control needs to go to a 50k to HT. 50k 1 watt. 250 volts through a 50k resistor to ground. V equals IR, I equals V over R. So I equals V, which is going to be about 250, maybe 280, let's go for 280, over R, which is 50k, which is 5.6 milliamps. P equals IV, multiply that by 280, 1.5 watts. That's a 1 watt resistor that can dissipate 1.5. but only at full volume. So the wiper would have to be at this end dumping the HT straight to ground. 50k will develop about 1.5 watts at full volume. So 1 watt is probably a cost cutting measure, because I imagine bigger than 1 watt was probably more expensive, and they probably assume no one will run these full noise. So that's my theory. Yeah, well, we'll see how warm that gets.